In this video, we'll be looking at some applications of permutations and combinations. So just a reminder, permutations are used when order is important. So examples of that are the number of ways the positions of president, secretary, treasurer can be filled, the number of ways a team can be chosen from a squad in distinctly different positions, or the number of ways the first three positions of a race can be filled. So filling first, second, and third is different from filling second, first, and third. Combinations, on the other hand, are used to count when order is not important. So, for example, the number of ways a committee can be chosen, the number of ways a team can be chosen from a squad, or the number of ways a hand of 5 cards can be dealt from a deck. So, example 19a. We're told 10 points are marked on a page, and no 3 of these points are in a straight line. Determine how many triangles can be drawn by joining these points. So in this example, we have to determine, is order important? So if we had a triangle with point A, B, and C, is that any different from creating a triangle using B, C, and A? Well, no, because the lines connecting them are going to make a triangle no matter what order they're in. So this is going to be a combination. So our formula is NCR. We have 10 points to choose from, and we're choosing 3 points from that group of 10. So that becomes 10 factorial over 7 factorial, 3 factorial. So we can take the 7 factorial out of the 10 factorial. We're left with 10 times 9 times 8 over 3 factorial, which is going to give us 10 times 3 times 4 by taking out the factor of 3 from 9 and the factor of 2 from 8. And that leaves us with 120 different triangles that we can make by joining 3 points. In part B, we're trying to make different 3-digit numbers. So if we've got 1, 3, 5, 7, and 9, we can realize that 1, 3, 5 is not the same as 5, 3, 1, for example. So this is going to be a permutation. So our formula is NPR. We have 1, 2, 3, 4, 5 different numbers to choose from, and we are choosing 3 numbers to make our 3-digit number. So that gives us 5 factorial over 2 factorial, which is just equal to 5 times 4 times 3, which is equal to 60 different 3-digit numbers that we can make. Example 20. Jade and Kelly are 2 of the 10 members of a basketball squad. Calculate how many ways a team of 5 can be chosen if both Jade and Kelly are in the 5, neither Jade nor Kelly is in the 5, or Jade is in the 5 but Kelly is not. So in part A, both Jade and Kelly are already in the 5. So if you imagine these are the 5 slots that we have to fill. Jade's already locked in, Kelly's already locked in. So they're 2 of the 10 members. So there's 8 people left to choose for these last 3 slots. So doesn't matter what order these people are in? No, because there's no roles for them to fill. So that's going to be 8, choose 3, which is equal to 8 times 7 times 6 times 5 factorial over 5 factorial, 3 factorial. So that's just a factorial over 5 factorial, 3 factorial. Those 5 factorials cancel. The 6 cancels with the 3 factorial. We're just left with 8 times 7, which is 56. Okay, well, what if neither of them are in the 5? Well, then instead of choosing from 10 people, we're just choosing from 8. So this becomes 8, choose 5, which is equal to 8 factorial over 3 factorial, 5 factorial. Hey, we've already calculated that in the previous example. So 8 choose 5 is the same as 8 choose 3 because combinations have a symmetric property. And we'll look at that a little bit further when we're looking at Pascal's triangle. So this is also equal to 56. Part C. Jade is in the 5, but Kelly is not. So we've locked Jade in. We've got 4 slots left to fill. But how many people do we have to choose from? So we had 10. We take out Jade. We take out Kelly. So there's 8 left for us to choose from. So this becomes 8 choose 4, which is equal to 8 factorial over 4 factorial, 4 factorial, which is just 7 times 2 times 5, which is 70. So there are 70 different ways to pick a team that Jade is in, but Kelly is not. Okay, so for lotto systems, there's information in the Jacaranda textbook about lotto systems, but for example 21, the main thing we need to know is what this system 8 entry is referring to. So say you had 7 lucky numbers, 4, 7, 12, 21, 30, 38, and 45, and you wanted to include all possible combinations of those 7 lucky numbers in a 6 numbers lotto entry. To do that, you'd buy what's called a System 7 entry, which will take those 7 numbers and make all the possible combinations of 6 numbers using them. So order doesn't matter here. In a lottery, your numbers are always ordered in numerical order, but you'd get 4, 7, 12, 21, 30, 38. Then you might also get one with 45 instead of 38. And so you're building this group that covers all possible groupings of 6 numbers out of your 7 lucky numbers. So in this case, we have a System 8 entry, and we have 8 lucky numbers that we want to choose. The official draw was 4, 8, 12, 15, 22, 36, and we have 2 supplementaries, 20 and 29. So the way the divisions work is to win Division 1, you need all 6 winning numbers matched. Division 2, you need to have 5 winning numbers matched and 1 supplementary number. Division 3 is 5 winning numbers, Division 4 is 4 winning numbers, Division 5 is 3 winning numbers. So how many single entries are equivalent to a System 8? So we have 8 numbers, and we want to choose 6 from them. So it's going to be 8C6, and so 8C6 is just 8 factorial over 2 factorial, 6 factorial, which is going to be 8 times 7 over 2 factorial, which is just equal to 4 times 7, which is 28 entries. So if you bought a System 8, you would get 28 possible combinations of your 8 numbers. List 3 of the player's entries that would have won Division 4. So just a reminder, Division 4 means you have 4 winning numbers. So some possibilities would be 4, 12, 22, 36, then 7, 9. So we have those 4 numbers that match the official draw, 4, 12, 22, and 36. Another option could be 4, 12, 22, 36, 7, and 29, or 4, 12, 22, 36, 7, 32. So you can see that we're locking in the 4 winning numbers and just moving around the other 2 possible entries. Okay, part C. Determine how many of the player's entries would have won Division 4. So, to win Division 4, the numbers 4, 12, 22, and 36 must have been chosen. So we're locking in those 4. So that's 4, 12, 22, 36. And we have to pick 2 other numbers for our entry. So those 2 numbers get picked from the System 8 options. So what do we have left? We've got 4 numbers to choose from. So 4 choose 2 is going to be 4 factorial over 2 factorial, 2 factorial, which is 4 times 3 divided by 2, which is just 6. So 6 of the player's entries would have won Division 4. And that's all for this video. Thank you very much.